Hello champion, welcome to my math class. Today I'm going to teach you the unit of ratio and scale. We are going to learn how ratio and scale relate and how we are able to use the ratio to show given measurement in the map. We are going to learn how ratio is being used in maps and how we can use ratio to determine distance of object in a particular map. So, and actually also what we are also going to learn, we are going to learn about map scale and we are going to learn about the actual scale. We're going to see how it's possible when you're given a map scale and then you're supposed to convert it into actual scale. What do you do? Like for example, if you want the actual distance of an object that were 4 centimeters apart on the map, how can we get the actual distance in kilometers or in meters? So those are the kind of things that we're going to learn. So the first thing, luckily on our previous class, we learned about ratio. We know what ratio is. And today we're going just to continue with the same knowledge of ratio and scale. So this is also one of the most asked question. This unit, the knowledge of knowing how to read scale is very important, and how to analyze it when you're given a specific ratio. Because the same knowledge you are going to, it's going to be tested on your final IGCSE exam, whereby you might be given the same knowledge can be used in bearing too. Like for example, if they want the distance between two objects that are maybe 30 degrees and one is 220 degrees from a specific direction, and then you're asked to locate, and then later on they want you to estimate maybe A and B is maybe 11.2 centimeter. What's the actual distance in kilometers? You'll be given there the scale down. Scale is a guideline. Obviously, we understand that we need to have a scale to draw things on a piece of paper. So a scale is a small unit that helps us to bring the bigger imagination of an object into a presentation. So whatever you see in a scale is just a presentation of an actual big object. So whatever you have on a map is just a presentation of what architectures were thinking on actual distance. For example, on a map you might have maybe this is like, maybe this can be our map. Let's say this is a map, and we call this is a map of let's say Dar es Salaam city. So we're talking about a map of Dar es Salaam. And we say on the map of Dar es Salaam, maybe we have a road, we have a specific road that is going that way, and then we have another road that is coming this way. And we say we can say this road is let's say 8.5 centimeter long. So you can see, actually, for example, if you're looking, maybe let's say the distance between we have Bagamoyo and Kariakoo. So we have Bagamoyo and Kariakoo, and then we say this is 8.5 centimeter or 18.5 centimeter. You are asked to find the actual distance. So if you really think about it, let's say find an estimate of distance from Bagamoyo to Kariakoo. Bagamoyo to Kariakoo, let's say around 60 kilometers. So if it's 60 kilometers and you have to draw that on a piece of paper, it will be very long, very long. Because of the scale, we are able to bring that 60 kilometer unit into smaller units. So these smaller units help, first of all, they save space and also they save time. So that's important. Scale is a ratio. So that's the first thing we need to know. So a scale is a ratio. It can be expressed as length on drawing, real length. Correct. So we say a scale is a ratio. It can be expressed as length on drawing to real length. So that one. And then we say, so sometimes the scale of a map plan or model is usually given as a ratio in the form of 1 to n. For example, the architects who designed the new Louvre building for Abu Dhabi made a 6-meter wide scale model of the domed roof using aluminium rod to test how light would enter the dome. The scale of this model is 1 to 3. So a scale of 1 to 3 means that a unit of measurement on the model must be multiplied by the 3 to get the length in the same unit of the real building. So if the diameter of the dome in the model was 6 meter, then the diameter of the real dome will be 6 meter times 33, which you get 198 meter. So expressing a ratio in the form of 1 to n. So we know that ratio are expressed in the form of 1 to n. So how do we express a ratio in the form of 1 to n? So all ratio scale must be expressed in the ratio of 1 to n or n to 1. So to change a ratio so that one part is equal to 1, you need to divide both parts by the number that you want expressed as 1. Yeah, example. We express 5 to 1000 in the form of 1 to n. So our idea here, we have to 1, the first part of the ratio should be 1. So to get 1, you have to divide both sides by, so in this case, divide both sides by common factor 5. That will give you 1. So 5 divided by 5, and then to 1000 divided by 5. So 5 divided by 5 is 1. 1000 divided by 5 is 200. So 1 to 200. And that's it. So in the form of 1 to n. Another example, express 4 millimeter to 50 centimeter as a ratio scale. To express 4 millimeter to 50 centimeter as a ratio scale, what you're supposed to do, you need to express the amount in the same unit. So one is in millimeter, the other one is in centimeter. So you can choose. So I choose millimeter. 4 millimeter to 500 millimeter, because you have 50 times 10. You get, because 10 millimeter is equal to 1 centimeter. So multiply 50 times 10, you get 500 millimeter. Now, because they're in the same unit, now we say the rule is 1 to n. So the rule here is 1 to n. If the rule is 1 to n, divide by 4 both sides. 4 divided by 4, 500 divided by 4. So you get 1 to 125. You get that? Nice one. Now we go to, we have another example, right? 22.4 in the form of n to 1. So what do you do in that case? So you have 22 to 4 in the form of n to 1. Because they want in the form of n to 1. So divide by 4. 22 divided by 4 to 4 divided by 4. What do you get? 1, 2. 22 divided by 4 is 5.5. Solving scale problems. There are two main types of problem involving scale. One, calculating the real length of object from a scale diagram or model. And then real length is equal to diagram length times scale. And then we have 2, calculating how long an object on the diagram will be if you are given the scale. Diagram length is equal to real length divided by scale. And then you end up getting the correct answer. So in that case, we say there are two main types of problem involving scale. So we have calculating the real lengths of objects from a scaled diagram or model. So we say real length is equal to diagram length times the scale. Correct. So this is also very important. Then you say calculating how long an object on the diagram will be. Calculating how long an object will be if you are given the scale. So say diagram length, real length. Correct. Example. The scale of a map is what is the real distance between 2 points that are 5 centimeters apart on the diagram? That's A. Express the real distance in kilometers. So that's another way. We say, what's the real distance between 2 points that are 5 centimeters apart on the diagram? So the real distance, you just take 25 you take 5 centimeters times correct. So the real distance is 105,000 centimeters, and then say express the real distance in kilometers. So you express it in kilometers, divide by, so we say 1 kilometer is equivalent to 100,000. Then convert the distance. So we have 125,000 divided by 1.25. So we have 1.25 as distance kilometers. Do exercise 21.4. Do everything in exercise 21.4. See you at the top champion. I can't wait to see you in my next class. Bye bye.